Is exam 3. In this video I'm going to go over some of the problem from exam 3. So I'm going to start with problem number 1, and that is I'm going to give you a dt graph and you're going to convert this one to vt and at. Okay, so here is a dt graph. Okay, so let's do it. 2, 4, 6, 8 and 10. Time is in second. 4, 8, 12 and 16, and distance is in meter. Okay, so what do we know about it? So let's also draw a vt coordinate for vt graph. All right, let's also draw a coordinate for a vt graph. Okay, we need the first quadrant and fourth quadrant, and that's probably it. So 2, 4, 6, 8, 10. 2, 4, 6, 8 and 10. And this is again t is in second, and this is velocity in meter per second. All right. Okay. And here we're going to draw AT. All right, so here we're going to draw AT. We probably need only the fourth quadrant. Okay, only the fourth quadrant, and that would be it. So acceleration, which is in meter per second square, and time, which is in second, and time we already know, 2 and then 4 and then 6 and then 8 and then 10. Okay, all right, so let's see what we can do. So from 0 to 4 second, object move from 0 meter to 8 meter. Okay, object spend 4 seconds to move 8 meter. All right, so let's draw this a diagonal line. Okay, all right, so a diagonal line. So object move from 0 to 8 meter is spending only 4 seconds. Okay, so then object velocity is of course constant. How can we find this constant velocity? Okay, let's find it. Velocity is df minus di tf minus ti, and that is df is 8 minus di is of course 0, and tf is 4 minus 0, so 2 meter per second. Object velocity is 2 meter per second at section 1, and now that's what we're going to draw, 2 meter per second. So we're going to quickly put 2 over here, 4 over here, 6 over here, 8 over here, and -2, -4, -6 and -8. We don't need that much. Okay, so it's going to be 4, 2. So object move with constant velocity, and that is 2 meter per second from 0 to 4 seconds. Okay, so object moves 2 meter per second from 0 to 4 seconds. Okay, so this is not obvious, so I'm going to make this running out of ink. Okay, so this is much better, So this is location 1 or section 1. Okay, now from 4 to 6 seconds, object is at rest. So at 4 second object is at 8 meter, and 6 second object is at 8 meter. So object is not changing its position, so object is at rest. Object is at rest means object velocity is 0. So object velocity is 0 from 4 to 6 seconds. All right, that's cool. All right, so now what we can do, we're going to draw entire graph. So from 6 to 8 seconds, at 8 second object is at 16 meter. Object is at 16 meter at 8 seconds. So 16 at 8 seconds. So this is where I try to draw the acceleration or a quadratic or parabola. Okay, all right, that's more or less look like it. And 8 to 10 object at 10 second object back to 8. So back to 8 at 10 second object back to 8. Okay, object back to 8 at 10 seconds. So I'm going to try to draw that one now. Okay, good. All right. Okay, so what does that mean? This part object, of course, accelerating. Made it worse. I'll try it better a little. Okay, good. All right. On the top. Okay, this is top. Okay, so far so good. Okay, let's find the distance at each location. This is 1, this is 2, this is 3, and this is 4. All right. The distance object travel is 8 meter at section 1. Distance object travel is 0 meter at location 2. Section 3, distance object travel is also 8 meter. And section 4, the distance object travel is also 8 meter. Remember, distance is positive. You take the absolute value of negative and you get the positive. So distance 8 meter. All right. So now what are we going to do? We're going to draw a VT graph for section 3 now. How can we do it? We need the initial velocity. So we're going to do the calculus. All right. So let's first do it by geometry. Distance is, let's write it down over here. The distance is for location 3. Distance is the area under the curve. That's the distance. So distance is area under the curve. Okay, good. So far so good. And the distance is 8 meter. We already see that distance is 8 meters. So half. And it takes how long for object to move 8 meters? All right, it takes 2 seconds, 6 to 8, 2. And h, when you talk about VT graph, h become velocity. So velocity is 8 meter per second. So initial velocity for section 3 is 8. So velocity is 8. Okay. Initial velocity is 8. 8 is somewhere there. If this velocity is 8 meter per second, then this velocity right here negative 8 meter per second, because this is parabola and parabola is symmetric. And this velocity is of course is 0. Why is that? Because the velocity is positive, acceleration is negative. So velocity is decreasing from 8 to become 0. And velocity and acceleration is the same direction. So velocity and acceleration same direction, object is speed up, so it's from 0 to become negative 8. That means object velocity is 0 at 8, right? Object velocity is 0 at 8, so 8 object velocity is 0, and object velocity is negative 8 at 10 second, negative 8 at 10 second. All right, negative 8. We're going to verify it by calculus, of course. Negative 8. So this is positive 8, this is negative 8. So now let's verify it now by calculus. All right, first here we're going to start our conversation. P of t is equal to at squared plus bt plus c. And then, of course, P of t, first we're going to use this point 6. So 6 is equal to 36a plus 6b plus c. All right. Now, what is P of 6? P of 6 is 8. So 8 is equal to 36a plus 6b plus c. All right. So this is our first equation. The second one, we're going to use now 8. So P of t is equal to at squared plus bt plus c. So P of 8 is 64a plus 8b plus c. At P of 8, distance is 16. So 16 is equal to 64a plus 8b plus c. All right, now of course no time will be left behind, so P of t is equal to at squared plus bt plus c. So 10 is equal to 100a plus 10b plus c. At 10, position is 8. So 8 is equal to 100a plus 10b plus c. So we have three equations, and we call them system of equation. There's the name. Okay, so now our goal is to find the value of a, b, and c. So our goal is to find value of a, value of b, and value of c. Let's see how can we find it. So let's write the last one. So you're going to write the last one, 100a plus 10b plus c is equal to 8. And this one, 64a plus 8b plus c is equal to 16. Okay. So what are we going to do? We're going to subtract from each other. Minus, 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 minus. So this cancel. So you have 36a plus 2b is equal to negative 8. All right. Okay, good. All right, now what we're going to do, we're going to do from this one to this one. Okay, so 64a plus 8b plus c is equal to 16. Okay, now we're going to do this one, 36a plus 6b plus c is equal to 8. Okay, we're going to do subtraction. So see cancel. So 14, 4, and then 5, 2, 28, 14, 6, 14 minus 6 is 28. 28 plus 2b, 28a plus 2b is equal to, of course, 8. All right, now we have this one and we have this one. Okay, so 1 minus 2, let's do it. So 36a plus 2b is equal to negative 8, and 28a plus 2b is equal to, of course, 8. Subtract from each other, cancel. You have 8a is equal to negative 16. So a is equal to negative 2. So we found the value of a. That's awesome. A is equal to negative 2. Now let's find the b. How can we find the value of b? It's easy. All right, so let's plug in equation 1. So equation 1 is 36a plus 2b is equal to negative 8. A is a negative 2. So 36 negative 2 plus 2b is equal to negative 8. So 72 plus 2b is equal to minus 8. So 2b is actually equal to 72. I'm going to go over there, become 72 minus 8. Okay, so this become 64, right? 64. 2b is equal to 64. B is equal to 32. All right, now we found the b. B is equal to 32. Now we're going to find the last one, c. So let's use this one. 36a plus 6b plus c is equal to 8. So a is equal to minus 2, b is equal to 32, plus c is equal to 8. Okay, so now this is minus 72 plus 92 plus c is equal to 8. So 192 is equal to 192 plus c is equal to 80. C is equal to 80 minus 192 is equal to negative 112. All right, so C is equal to negative 112. Voila, we find the equation. Finally, we would be able to write the equation. So the equation would be PT is equal to AT squared plus BT plus C, of course, for this one. So P of t is equal to A is negative 2 t squared plus B is 32t plus C is 112, negative 112. This is the equation for section 3 and section 4. Section 3 and section 4. This is the equation. What is the equation for this one? The equation for this one is y equal to 2x or P of t is equal to 2t. Equation for this one is y equal to 8 or P of t is equal to, of course, 8. And the equation for this one is right here. We already show you by the geometry. Now I'm going to show you by calculus. So this is the position function. Now from position to velocity, and here's what we're going to do. We're going to take the first derivative, p prime of t. So the derivative is very easy. Y is equal to xn. Y prime is equal to, being n over here, x n minus 1. That's it. This is called power rule. So we're going to use the power rule. This is what we're going to use. So we're going to bring the 2. So negative 2 times 2 t 2 minus 1 plus. We're going to bring down 1. So 32 times 1 t 1 minus 1, and derivative of constant is 0. So this is 4t negative 4t negative 4t, and this is just positive 32. And this is called velocity. First derivative, this is called velocity. All right, this is velocity, negative 4t. Now, we said that our velocity is 8 over here. Now let's see whether that's correct. At what time? 6. Put 6 here. All right, minus 4 and 6 plus 32. What do you get? Negative 24 plus 32. That's 8. And this is how we got 8 by geometry. So geometry is very strong, believe it or not. All right, so check. This is, you said velocity is 0. Let's check it at 8. So v of t at 8 minus 4 times 8 plus 32. This is 0. Okay, at a second 0. Check. And this is, we said, minus 8 at 10. So let's put 10. Velocity 10 minus 4 times 10 is 40 plus 32. Negative 40 plus 32 is, of course, negative 8. Check. All right, so this is our velocity. Now we're going to take the acceleration. So this, I said this called p prime of t. Acceleration is p double prime of t, and we're going to do it same way. So negative 4, the exponent is 1, bring it down, t 1 minus 1 plus the derivative constant is 0. Okay, now rewrite it. Negative 4, t to the 0 is just 1, so it's negative 4. Negative 4. And we're going to call this one velocity, and we're going to call this one acceleration. And this is the calculus, right? Okay, so acceleration is negative 4, believe it or not. But we don't need this calculus. You can do by algebra, by geometry, because geometry is stronger than calculus. Well, but anyway, I don't. So negative 8 is negative 10 comma negative 8 is 6 comma 8. That's why I'm struggling. This should be 6 comma 8. This should be right here. All right, so let's connect it. Okay, so let's do this by this. All right, so this is this, and this one is this. Okay, now we're gonna make it triangle because we have to show that this area is 8 meters. So area is 8 meters. So this area is 8 meters. And we have to also show that this area is 8 meters. Absolute value of this area. Okay, this area is also, this is negative 8 meters. All right, so we're going to find the distance and displacement now. So the distance is, this is 8 meters, 8 plus this is 0 plus this is 8 plus this is absolute value of 8, because distance can never be negative. So 24 meters. Now displacement, this is 8 plus 0 plus 8 and minus 8. Minus 8 plus 8 cancel, so displacement is also 8. You can do displacement directly. 8 minus 0 is 8. You can of course do the displacement like that. Now you're going to draw acceleration versus time graph from right here. All right, so let's do it. If the velocity versus time graph is horizontal, acceleration is 0. Okay, if this is horizontal above the x-axis, this is horizontal 0. If this is horizontal 0, this one has to be horizontal 0. Now this is there is an acceleration over here, and that's what we're going to find. So acceleration is velocity final minus velocity initial t final minus t initial. Velocity final is negative 8. Velocity initial is 8. T final is 10 minus 6. So minus 16 over 4. So this is minus 4. So acceleration is minus 4 from 6 to 10. So minus 4 from 6 to 10. From 6 to 10, acceleration is minus 4. And that was beautiful, right? Okay, good. Now, the second part is going to be easy, very easy. All right, so I throw a ball, the question number 4, I throw a ball in the air. So if I throw a ball in the air, it comes back to my hand. So I can call this is location A, and this is location B, and this is location C. All right, I want you to draw vectors, acceleration vector and velocity vector at from A to B and from B to C. All right, so the velocity vector over here is positive and velocity vector over here is negative. Acceleration vector over here is negative and acceleration vector over here is negative. Velocity vector and acceleration vector, they are opposing each other. They are opposing each other. So object is slowing down. They are same direction, so object is speeding up. Okay. Another one I'm going to show you. I want to show you velocity vector and acceleration vector at 3 locations. Of course, this is a here, 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 and here. So let's first draw velocity vector. Velocity vector, velocity vector, velocity vector. And the velocity vector. So what do you see? This one and this one are equal in magnitude, opposite in direction. The velocity is becoming smaller, getting 0, getting bigger, because this one and this one are same in magnitude, opposite in direction. This one and this one same in magnitude, opposite in direction. Now acceleration vector is always negative and is constant, meaning the same size. So acceleration vector is same size, is never changes, but velocity vector is velocity is losing, velocity is slowing down, becoming 0, and velocity is speeding up. Okay, let's say I throw a ball. I throw a ball, 3 locations of course, A, B, and C. I throw a ball with initial velocity 15 meters per second. I want you to find this thing, location A, location B, and location C. I want you to find many things. Number 1, I want to find initial velocity, time, displacement, distance, velocity, speed, and acceleration. Initial velocity is 15 at location A, B is 15, and C is also 15. The time, let's find the time. Before I find the time, let's find the final velocity. Velocity is 0 over here, right? And velocity is negative 15 over here. Okay, so let's write it down. Velocity at location right here is 0, and velocity is minus 15, and velocity is 15 over here. And let's use this information, but quickly finish this one, 15 and 15. And this one is negative 10, negative 10, negative 10. And okay, and this one is velocity 0, time is 0, and now the following information we're going to find it quickly. So right over here time, so Vf is equal to Vi plus At. So this is negative 15 and this is positive 15 minus 10t. So t is equal to 3. So this is t is equal to 3. So this t must be half. T is equal to 1.5. So t is equal to 1.5. Now displacement, let's find the displacement two ways. Vf square is equal to Vi square plus 2AD. So Vf square is 0. Of course, velocity over here is 0. So this is 15 square minus 20d. So d is 15 square over how much? Over 20. So d is equal to 11.25. You can also find it Vit plus half At square. So d is equal to 15t. T is how much? 1.5 minus 5, 1.5 square. This is 11.25 both case. So displacement is 0 over here, 0 over here at B, 11.25, 11.25. Displacement is 0, displacement is 22.5. Done. Now I'm going to go over the problem number 1 on the test. This is a reward for you to stay half an hour. So problem 1 on the test. Okay, so two cars on the road. The car A is 200 meter behind, 200 meter behind, then car B. Car A is moving with 20 meter per second. Velocity of car A. Velocity of car B is 15 meter per second. The question is, at what distance the car A will meet with car B? How can we do that? Let's represent car A with different color. (20 meters per second). All right. So what are we going to do? So now we know that d is equal to d initial plus Vit plus half At square. We know that this is for car A. This is d is equal to di plus Vit plus half At square. Okay. So now d is equal to di is this is behind. So Vi is 20. So 20t, acceleration is 0. Now this one is d is equal to, this is 200 meter ahead. So put 200 plus Vi is 15 t, acceleration is 0. So 0, right. So now we're going to set both of the equation each other. So you're going to say dA is equal to dB. So dA is 20t is equal to 15t plus 200. Okay, so what are we going to do now? 20t minus 15t is equal to 200. So 5t is equal to 200. So t is equal to 40. All right, now we're going to plug this information over here. dV is equal to 200 plus 1540. So 800 or meter. Or we can do it over here. D is equal to 2040. So 800. So after 800 meter, so somewhere here, the both car meet with each other. 800 meters.